Hello, this lesson is on adding and subtracting fractions. It's a topic I know you're working on in school right now, so we're going to take a look at what we need to do in order to make that happen. The first thing you need to be aware of when you're adding and subtracting fractions is when you add and subtract fractions, you must have common denominators. Common denominator, of course, means that the denominator needs to be the same. Now, in this first problem that we're going to work through, you can see that the denominators, the number on the bottom, is already the same. They're both 4s, so it's a nice, easy place to start. Since they are already both 4s, we can just go ahead and bring that over, and that's going to be the bottom number for our answer. And then we take a look at the top numbers. First top number is 3. The operator that we're looking at here is addition, so we'll say plus, and then the last number is 2. 3 plus 2 is 5, and we have 5/4. Now 5/4 is an improper fraction, and depending on the circumstances in your class, your teacher's preference, or even the context of the problem that you're working on, this may be an appropriate way to leave your answer as 5/4, or you may need to go back to those skills that you have on creating mixed fractions, and of course 5/4 is the same as 1 and 1/4, and I would check with your teacher in the context of the problem to decide which is the most appropriate way to leave your final answer. So let's take a look at a few other problems, beginning with when you see that the denominators, they're not common, or they're not the same. Now the technique I use when I do this, it might be a little different from what you're doing in your own classroom. In your class, you're probably thinking about the words lowest common denominator, which is fine and it works really well. But if you're having any trouble discovering what that lowest common denominator is, you can really just go ahead and find a common denominator and then worry about whether or not it's the lowest later. So a little pattern I like to do, and it's a little picture, is this right here. And that's a path of multiplication, because that's all we're going to do right here is multiplication. This line that I made across the bottom, that's our denominators. And our denominators here, 5 and 9, 5 times 9 is 45. And at least to start with, that's going to be our denominator for the final answer. Then we'll go ahead and take a look at our first arrow, which went this way. And we're going to multiply those two guys together. 3 times 9, 27. Again, we're going to keep this same operator, addition. And we're going to multiply these two together. 5 times 7, 35. And we've got all the things that we need in order to add these two fractions together now. Add 27 and 35. 7 and 5 is 12. There's our 2. 2 and 3 is 5, plus the 1 we carried over, that's 6. And that's going to be over the number 45. Again, it's an improper fraction, so it's between you, your teacher, and the context of the problem to determine if this is an okay way to leave the answer or if you need to convert it into a mixed fraction. But I can say right now, this is the final answer. And I could tell because when I looked over here at the original problems, the numbers 3, 5, 7, and 9, well, it didn't really have a whole lot in common here. And as I'm looking at the numbers 5 and 9, well, 9 times 1 is 9. 9 times 2 is 18. 9 times 3, 27. 9 times 4 is 36. 9 times 5 is 45. That's the first time that 9 and 5 have something in common. So for this particular example, we're able to leave it with this answer, and our little trick here worked just fine. In a few later problems, we are going to need to reduce it further, but we'll get to that a little bit later. This next problem does have a little bit of a change to it. we have a negative sign. Now, when I work with any students, I always let them know that the negative sign should be grouped with the numerator of the fraction that you're looking at. But again, what we did on our last problem, we're going to do the exact same thing in order to get our common denominator. Across the bottom, we have 3 and 8. 3 times 8 is 24. Now this time we're going to be doing 8 times negative 2, which is going to be a negative 16. And then 3 times 5, which is going to be a positive 15. And again, just like our prior problems, the operator is addition, so that's a plus in between. Negative 16 plus 15. The negative one is the larger one, so our answer is going to be a negative 1 over 24. And then just for neatness sake, let's go ahead and move this negative that we have here back down to the middle so that we can indicate that it is applied to the entire fraction, that this is negative 1/24. And again, that's about as reduced as you can get it. It is 1 out of 24. There is nothing in common between those two numbers. So let's go on to the next problem. So with this slide, we're going to start subtracting fractions. Now, you may already recognize that this problem is a lot like the last one. The last problem, we had a negative sign. This time, we're doing subtraction. And remember, negatives, when you're adding any negative together to a positive, is much like doing subtraction. But our way of working is going to be exactly the same. I'm going to draw that pattern again for you. We're still going to do 8 times 3 on the bottom, which is 24. We're still going to do 3 times 5, which is 15. And this time, we can look at it one of two ways. We can say that 8 times 2 is 16, and the operator that we have this time is minus instead of plus like our prior problems. So we can say 15 minus 16. Or if you prefer, we can go back to what I had said earlier, that we'll just combine the negative sign with the numerator. 8 times negative 2 is negative 16, or 15 minus 16. So this time, 15 minus 16, that's negative 1 over 24. And just like on the last problem, let's go ahead and move that negative down to the middle to indicate that it is, for the entire fraction, negative 1/24. So we're doing pretty well on these here. So what will happen if we actually combined two negatives? What we have this time is a negative number out front and subtraction in the middle. We're still going to approach it the exact same way. Across the bottom, multiply at an angle to the left, at an angle to the right. On the bottom, we have 2 times 11, that's 22. And this time we're going to go back to what we were talking about before and grouping the negative symbol with the numerator. 11 times negative 1 is negative 11. And 2 times negative 3 is negative 6. Both numbers are negative, and as you remember from adding and subtracting integers, if they're both negative, we are going to increase the magnitude of what we're looking at. So 11 and 6, that's going to be a negative 17 over the denominator, 22. And finally, all we need to do is move that negative down into the middle to indicate that it is the entire fraction that is negative. And even this step right here, you'll want to reference your teacher's instructions. Some don't even need you to do that last step, but it's a good idea. So what does all this mean if we want to combine it into real context in a word problem? Here we have Olivia, who ate 1/8 of a pizza, and Katie, who ate 1/4 of a pizza. How much more pizza did Katie eat than Olivia? Okay, well, we have Katie's fraction, which is 1/4. And we have Olivia's fraction, which is 1/8. But it didn't really tell us what operation to do. That's where we're going to need to look for some clues within the word problem to decide what to do. And the question that's asking is how much more? How much more, or how much more than, implies that we're going to be subtracting. We want to know the difference between 1/4 of a pizza and 1/8 of a pizza. So we're going to do 1/4 minus 1/8 to see what the answer is. The reason we put it here first with 1/4 is we want to know how much more Katie, with 1/4, ate beyond Olivia, who had 1/8. We're going to do the same thing we've been doing since the denominators are not the same. 4 times 8 is 32. 8 times 1 is 8. And 4 times -1 is -4. Which leaves us with 8 minus 4, or 4 over 32. 4 and 32. Now, if you are familiar with reducing fractions, you're probably looking at that and thinking, well, you know, we really should do something about that because the number 4 does go into 32. In fact, we just did it right here. 4 goes into 32 8 times. So when we reduce that, 4 going into 32 8 times, the final answer to this is 1/8. Could we have done that getting a lowest common denominator? Yes. But if that's not something you're comfortable with, this method will work for you every time, as long as you remember to reduce your final answer. And then one more word problem I want to look at today is going to involve John, who ran 3/16 of a mile, and Nathan, who ran 2/4 of a mile. How far did they run in all? And when it says in all, well, you can also think of it as saying all together, which implies addition. So we're going to be doing 3/16 plus 2/4. Now, the way you might do this in your own classroom with your teacher, you may already notice that 2/4, that's not reduced at all. But that's okay. We can handle that part later. We're going to go ahead and do what we have been doing for every other problem today, and multiplying 16 times 4. Now we're going to get a pretty big number here. 16 times 4 is 64. 4 times 3 is 12. And 16 times 2 is 32. We'll add those numerators together to get 44 over 64. But just like our last word problem, we're not done because this fraction can be reduced. You can tell since they both end with the number 4, might be a good thing to try the number 4. And just like we already experimented with, we know that 16 times 4 is 64. So 4 goes into 64 16 times. And 4 goes into 44 11 times, leaving us with a final answer of 11/16. Or how far did they run in all? 11/16 of a mile. And don't forget your units at the end of a word problem such as this. And that'll conclude our lesson on adding and subtracting fractions.